In this video, I want to take you through a visual proof of the area of a triangle and why it's 1/2 base times height. I know it might seem kind of intuitive, especially for right triangles, because you can see it's just a rectangle cut in half. But I think it's a little bit less intuitive when you look at acute and obtuse triangles. I don't recall it ever being proven thoroughly to me as a student growing up, and I think it's one of many formulas that we just kind of take for granted, and we don't actually try to figure out why it is what it is. So I found this proof, this visual proof, not only helpful to myself, but I hope also helpful to my students. So hopefully you'll find it to be the case for you as well. And again, we want to just start with reviewing the area of a rectangle, base times height. So we're going to be using this blue rectangle, this 6x8 rectangle, to work with, to go through a lot of these different cases for our proof. So if I have my height as 6 and my base is 8, my area is just going to be base times height, or 48 square feet. Cutting that in half will leave us with 24 square feet, because again, that's just 1/2 base times height. It's just half the area, so that makes sense. Again, the right triangle is pretty intuitive. But then we move that height line over a bit to the center, and we want to see, is it still true? Is it still going to be 24 square feet if I keep the base the same and the perpendicular height the same? And we can see that it does, right? Because we break it down into a subproblem of looking at these red triangles on the sides, right? This height line has perfectly cut that base in half on top. So I have 4 over here, 4 over here. 4 times 6 is 24. So both of these red triangles are 12 square feet. Adding that together is 24 square feet, leaving a negative space or a leftover area of blue to be 24 square feet. Okay, so let's try some other cases. If I shift the height line over such that it cuts the base into a section of 2 and a section of 6, I have a base of 6 over, a height of 6 over here and a base of 6. 6 times 6 is 36, half that is 18. Over here I have 2 times 6, 2 times 6 is 12, half that is 6. 6 plus 8 is 24, again, leaving 24 square feet of leftover area in blue. Okay, and you can pause at any one of these cases to see that it's true. I'll just show you a couple more. You kind of get the idea. You can prove this with multiple different numbers. The cool thing is the values do not change, right, in terms of the area. The red area will always end up being 24, and the leftover blue area will always end up being 24. I picked whole numbers because it works out the cleanest. It's easiest to see, and just to show some simple examples. But you can do it with any values, as we're going to see by just showing with an algebraic proof in a second here. So again, this is our setup. We have our blue rectangle. We have these little red rectangles cutting off some of the area to leave over this blue triangle that we're trying to find the area of. Okay? So let's look at an algebraic proof for a moment. We know the area of the rectangle is AB, right, because we talked about that at the beginning of the video, which is also equal to A times C plus D, if you think about it, right? So imagine these red triangles aren't here for a second. Just look at the rectangle for a moment. We recognize that B equals C plus D, right, because this segment plus this segment equals the whole bottom. So the area of the left red triangle is 1/2 AC, right, which we can see here. If this is a rectangle of height A and base C, the red triangle would be 1/2 AC. On the right side, we would have this red triangle would equal to 1/2 AD. So the area of the blue triangle then would be AB, the whole rectangle, minus 1/2 AC minus 1/2 AD. And we can rewrite that by factoring out the 1/2 and A to the front, bringing that to the front. If you remember distributive property, it's the reverse of the distributive property. So we're factoring out that 1/2 A, so that's in the front. We're left leaving C plus D in the middle, in the middle of the parentheses. And we recall that C plus D is just B, as we talked about. C plus D is just B. So we can rewrite that as AB minus 1/2 A times, in parentheses, C plus D is equal to AB minus 1/2 AB, which is just 1/2 AB. Okay, which is what we have here. One could also simply note that the height line forms 2 rectangles whose areas are AC and AD, which we also talked about, right? These 2 rectangles, these 2 smaller rectangles that we formed. The blue triangle is taking up exactly half of both of them, so its area is 1/2 of AC, right? 1/2 of this rectangle plus 1/2 of this rectangle, which is what we have written here. Again, we do that factoring trick where we say, well, C plus D equals B, which again just gives us 1/2 AB. So there's two fun little algebraic proofs written kind of differently, but essentially just the same idea. Okay, and so that there's a good proof for that. Visually, we're able to prove it with acute triangles. I'd like to take a moment and also prove it with obtuse triangles. Because again, I don't think it's necessarily intuitive to look at that and say, well, of course, that's 1/2 base times height. Before that, though, a quick word from our sponsor today, oxygen. That's stuff you need to live. If you use the checkout code O24LIFE, when you go to buy oxygen, you will get nothing because oxygen is free. Make sure you breathe plenty of it. It's good for your lungs. You need it to live. Moving on. Let's now talk about obtuse triangles. We have a height of 6, base of 8. Height of 6, base of 8 like we had before. I'm just changing the color. We have area still 48 square feet. Okay. Notice all the pieces here. I have 24 square feet here by having this height line right in the middle. 12 square feet here. Okay. Again, the base is 4 here, the base is 4 here. Watch what I do here. So again, this purple triangle is 12 square feet. I'm going to add an extra 3 square feet right here by adding this little triangle to this rectangle, making a new shape. If you recall, this is a trapezoid, okay, with an area of 27. Okay, so now the area I want to focus on is this purple area, which is 9 square feet. Because again, remember, this plus this plus this needs to always equal 48. Because we're not changing the overall rectangle, I'm just moving some things around with inside. So for right now, I have 27 square feet here, 12 square feet here, 9 square feet here. Let's see what happens as I start to move this height line over this way. When I split it this way, this is now 3, this is now 5, this is always 6. 6 times 5 is 30, half that is 15. 3 times 6 is 18, so this rectangle is 18. This triangle here has a base of 2, right? Because if this is 3 and this whole thing is 5, this part must be 2. 2 times 6 is 12. Half that is 6. Totaling this whole section up to 24 square feet. Okay? So we have 15 square feet here, 24 square feet here, 9 square feet here. Okay? Move it again. You get the same idea. Okay? And you can pause it if you need to work out any of the numbers, but it's pretty intuitive. And again, notice as I'm moving it, the whole point of this is as I'm moving it, the base of the purple triangle is not changing, the perpendicular height of the triangle is not changing, and notice the area inside the triangle is not changing. Okay? That's the whole point here. That's what we're trying to see. We're trying to determine that. And so again, if we keep the base the same and we keep the perpendicular height the same, we will always end up with the area inside the triangle being the same. Okay, so hopefully that was helpful to some of you to see that proven somewhat rigorously. Hopefully helpful with the visuals, and I hope that was helpful to you. So thank you for watching, and I'll see you in the next one.